Hello, this is Mrs. Pullen for AP Stats Lesson 8.03. In this video, I'm going to go over the four-step process we use to construct confidence intervals for proportions. So we're going to go over example 2. A manufacturing company specialized in steel-based technology routinely samples their products for quality control. A particular type of small steel plate used in electric motors is called a lamella, requires a thickness of less than 0.35 millimeters. In a random sample of 800 lamellas, 98.3% met the thickness requirement. Over 300,000 lamellas are made every day, and they specifically tell you in the problem that they want you to construct and interpret a 90% confidence interval for the true proportion of all lamellas that meet the thickness requirement. And generally with confidence intervals, they're going to tell you to construct one. So you're not really guessing which inference procedure. However, sometimes the problems will tell you if it's a proportion, and sometimes they'll tell you if it's a means. In this case, they told you, sometimes they don't tell you which one it is, but here they told you it was a proportion. How can you tell if they didn't? Think about the data that's being collected. You're asking the question, did the lamina, is it less than 35 millimeters or isn't it? So that's a yes or no question. If the data that you're collecting is yes or no, then you're going to analyze it using a proportion. If the data that you're collecting is some sort of measurement, whether it's time, length, height, weight, volume, money, then it would be the means. So that's what we mean by categorical versus quantitative data. So you're going to decide on your procedure, and this procedure is actually called a one proportion Z interval. And I'll show you a neat way later in the video of how you can look up the names using your calculator. So once you decide on the procedure, then you have to define your parameter. So the parameter is the true proportion. So this is going to be P equals the true proportion of all laminas that meet the thickness requirements. Please make sure that your P does not have a hat, because otherwise I have to take off a point, and make sure that you have a symbol and that you define it. Step 2 is to check the conditions. So the first condition is random selection or random sample as stated. Sometimes it's a simple random sample. The purpose of it is that allows you to generalize your results to the population, in this case, all lamellas. The second condition is the 10% condition, and we need it because we're sampling without replacement. So you could write it's reasonable to assume and blah, 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 but in this case, we actually know the population of lamina. So it's reasonable to assume that there are more than 8,000 laminas produced each day. So we don't even have to use the word to assume. We could have just said there are more than 8,000 laminas produced each day, but they wouldn't take off points for that on the AP exam. The next part is the large count condition. You use the large count condition, not the CLT, when you're dealing with proportions. So that's NP hat. So in this case, it's going to be 800 times 0.983, and that's equal to 786, and that's certainly greater than 10. and you have to write greater than 10. And NQ hat, that's going to be 800, and 1 minus 0.983 is 0.017, and that's equal to 14, which is greater than 10. And so we just met that condition. Now you have to have a summary statement, and we just met the condition, so you say it. Since conditions have been met, and we then say we can construct the one proportion Z interval. So that's step 1 and 2, and that does take a lot of time to write out. Step 3, we actually do the calculations. So you need to look up the formula. So let me show you where the information from the formula is. You would go to the reference sheet, which you should always have out at all times. And if you go to the bottom of the first page, you're going to see it says in section 3, that second row, confidence interval, statistic plus or minus the critical value times the standard error of the statistic. That's the general formula. Go to page 2. We're dealing with one proportion. That first row is what you're going to end up using, and the statistic or the point estimate is the p hat. That's from the proportion from the sample. I'm going to show you the critical value is the critical Z that we talked a little bit about yesterday. And then because we don't know P, we can't calculate this population standard deviation, but we can calculate the sample standard deviation, and that's SP. Notice they changed the symbol name. Square root of P hat, Q hat over N. So let's go ahead and now fill in that formula. So that formula is P hat plus or minus the critical value. And so we represent it with proportions with the Z with the asterisk, the square root of P hat, Q hat over N. Okay, well, the sample proportion is that 0.983 plus or minus, and now I'm going to show you how to calculate the critical value. So you're going to draw a normal model, and we're looking in this case at the middle 90%. So we're looking right here. So this is the middle 90%. So the critical values, they're the same thing. One's positive and one's negative, and that tells you how many standard deviations away from the mean you are. So if you have a z-score of 0, that means that's a z-score for what your actually mean is. This tells you how many standard deviations below the mean you are and how many standard deviations above the mean. So how do we get these values? What you're going to do is you're going to use inverse norm. So inverse norm, you need the percentile, so I need this area over here. And this distance, and I'll try to shade it in, this distance here and this area here and this area on the right are the same. So I'm just going to use the left. So I need that percentile. Well, how do I get that? I'm going to calculate alpha. Alpha, the whole normal curve is going to, the area is 1. So I'm going to subtract 1 minus the middle 90%, and that's going to give me 10%. And since those two areas are the same, I'm going to divide it by 2. So you get 0.05. And so that's the area here, and that's the area here. Then you're going to do that z-score, and you're going to do inverse norm, 0.05, 0, 1. And when you enter that in the calculator, you're going to get 1.645. 90% is used quite a bit in studies. 95 is the most, but 90% is used quite often. And so when you have 90%, since it's used so often, they want you to write it as 1.645. So you want to carry this one out to 3 spaces, otherwise you're going to have trouble on some of the multiple choice questions. So that's your critical value, and it's plus or minus. So that's what this is. So that's negative 1.645, and that's positive 1.645. That's your critical value. And so that's 1.645, and then you're going to enter the 0.983 and the 0.017 over n, and n in this case is 800. So I'm going to carry down the point estimate, and next what I want to do is I'm going to find the margin of error. The margin of error is actually this critical value times the standard error. So I go into, we're going to go to the calculator, and let's go to a calculator page, and you're going to go 1.645 times control square root, control division, and you're going to enter the 0.983 times the 0.017, and that's going to be over 800, and that gives you 0.0075. Let me just double check that. 0.0075. So the lower limit is 0.98 minus 0.0075, and the upper limit is 0.98 plus 0.0075. And when I subtract that out, I get 0.975, or at least that's what I got before. And when I rounded, I got 0.990. And after I do this problem, I'm going to show you the calculator step and what's required for you to write, because there is a shortcut. Okay, so now we do our conclusion, and as I spoke about the other day and the beginning of today's lesson, we have a sentence frame that you need to use. So if we look at that first page of the lesson, you want to say we are blank % confident that the interval from blank to blank captures the true proportion, and you want to write it in context. So let me go back. So we're going to fill that in here. We are 90% confident that the interval from 0.975 to 0.990 captures the true proportion, and in this case, of all lamellas that meet the thickness requirement. Now, there was a part B to this question. In order to show an improvement in quality from the previous year, the company must demonstrate that at least 98% of laminas meet the thickness requirement based on the confidence interval. Is there convincing statistical evidence that this goal has been achieved? And the answer to this is yes, because if you take a look at, and it's on the previous page, so I'm going to rewrite it. So the confidence interval that we stated on the prior slide was 0.975 to 0.990. Okay? And this should be, we can see that we have percentages that are below 98%. So we don't have evidence that we've achieved the goal that that above 90, what was their requirement again? That at least 98%, because you see we have values 0.975, 0.976 that are below, so we don't have convincing evidence that they've achieved their goal. So just a couple of other things that I mentioned I was going to show you. So if you go to menu and you go to statistics and you go to confidence intervals, we have a listing of all intervals. And I'll show you tomorrow too, and I'll show you what my expectation is on a test. Do you see where it says 1 proportion Z interval? Notice they list all these intervals. Z interval and 2 sample Z interval you're not to use. I'll explain more about that tomorrow. But we're doing a 1 proportion Z interval. You have to do the number of successes, but that's the NP hat if they don't give it to you as a fraction. So you would enter 786 over 800. And then you would change this to a 0.9 since we were doing a 0.9%, and you would hit OK. And notice they give you the 0.975 and the 0.990. So what would I expect you to show in the test? Because obviously the calculator does that. What do they require on the AP exam? They require you to show the substitutions into the formula. So what I'm highlighting in green here, like the check off here, and they would expect you to show the confidence level. So you must show the substitutions into the formula. You must show the picture of the normal curve with the proper shading, and then, of course, the other steps. So it does make the calculations much easier. You would still have to most likely calculate the critical value as well, because unless they give you 95%, chances are you may not know the others off the top of your head. I hope this video was helpful, and I will see you tomorrow.